Okay, we will now go through some tips for the AP Stats exam that I came up with, and I came up with 37 tips. So this is, first of all, some in general advice I have for you, but then also some specific content advice. And if this generates any questions, then, which it just might, this is, going to be a lot in here, then, please send me your questions. Also, you can go back and watch different videos on the different topics and the different chapters if this makes you think of something, and possibly look at it up in your Barron's book. But so I'm just gonna read through these pretty much and kind of say a few things. All right, so the test consists of 40 multiple choice questions, which you'll have 90 minutes to do. Then there'll be 6 free response questions, which you'll also have 90 minutes to do. And the number 1 through 5 in the free response should take you about 12 to 13 minutes each on average. And then the number 6 should take you about 25 to 26, as it is much longer than the others. And in regards to the free response, make sure you do number 6, okay? Because it counts 1/4 of your free response. I, in general, advise people to read all 6 problems first, and then go back, do the one they find to be the easiest. And then after that, go straight to the number 6 and do at least part of it, and then maybe go to another question, then come back to it, but certainly answer every part of number 6 as best you can to try to get at least a couple of points. Make sure and answer all the multiple choice questions, because there's no penalty for guessing, so don't leave any of those blank. This is a difficult test, so if you're missing half the problems, you're not doing that bad. So realize that you got to persevere through this thing. On the free response, if you can get 2 of the 4 points for each one of those, you're doing quite well. So do your best to answer every part of it, though. So I advise you to read all the free response questions before doing any of them, then go do the one you find to be the easiest. After that, go ahead and do at least part of the number 6, because the number 6 counts 1/4 of your free response grade. So it's critical you do your best to answer and get at least a point or 2 out of it. All right. In the FRQs, make sure and state the context in each part of the problem. Also, be careful to use the proper terminology and notation. So in every part, just go ahead and mention whatever the context is about. If it's about, people, or if it's about dogs or cars or whatever it is, in each part of the free response, make sure and mention that. Of course, make sure your calculator's charged. Make sure you have it ready to go. It'd also be a good idea to have a backup calculator as possible, even though really on the exam, you're going to not use your calculator as much as you think. It's a good idea to, to have a backup, or at least have a scientific one as a backup. All right. So really the only thing you need for the exam are pencils. You need pencils and your calculator. You don't need a pen. You don't need your formula sheet. The formula sheet will be provided for you. So that's all you need for the exam. All right, so here we go. So first of all, descriptive stats. So my first advice to you, when asked to describe a quantitative distribution, in other words, a list of numbers effectively, make sure and describe its center, its unusual values, which are its outliers, its shape, and its spread. In other words, the cuss. You could use the mean or median. Those are the 2 big measures of center. You could use the range, IQR, and the standard deviation to describe the spread. Those are the 3 big measures of spread. And when comparing 2 distributions, use comparative phrases like greater than, less than, or roughly equal to describe your center and describe your spread. If the distribution is skewed to the right, it has a tail going to the right, the mean will get pulled toward the tail. All right, and the median will likely be unaffected by the skewness. Thus, the mean will be larger than the median. In the left skewed distribution, the mean will be less than the median. So something like this, if that's right skewed, the mean is going to get pulled toward the tail. And the median is this point where 50% of the area is to the left, 50% is to the right, and the mean gets pulled over. And then here, this is distinctly left skewed. And so the mean would get pulled to the left. The mean would be smaller to the median. If the distribution are heavily skewed or has outliers, the median and the IQR are the best measures of center and spread to describe the distribution. So keep that in mind. If you notice the distribution is spread, the best measure of center, the best measure of the typical value is the median, okay? The best measure of spread is the interquartile range, which is Q3 minus Q1, all right? When describing a scatter plot, okay, mention the direction, the outliers, the form, and the strength. So the direction, is it positive or negative? The outliers are their points way above or way below the pattern of the other points. The form, is it linear or is there a noticeable curve? And strength, how tightly packed to the graph it is. So let's say if you're looking at a scatter plot like this would distinctly be negative. There's a very strong, and it's linear, okay, certainly linear. There's no noticeable curve, and very strong. And there's an outlier. There's a point that's way above the pattern of the other points. And so this one would be positive, linear, and strong. And there's no outlier. That's an influential point. It differs a lot in the X direction. So, so that is that. So whenever you describe a scatter plot, that's what you need to make sure and cover: the direction, outliers, form, and strength. So now, the next thing in linear regression that helps us out is the correlation coefficient, R, which will be given to you, or you can get it off your calculator. It tells us the direction and strength of a relationship. It does not tell us whether or not his data is linear. You have to look at the scatter plot or the residual plot to judge linearity. And so for this one, you know, so the R, remember, if the R is about 0.9 or less than negative 0.9, it'd be negative. See, this would be like negative 0.9 something. So in the 0.9s, and this would be like positive 0.9 something for R. All right, if it's in the 0.9s, that's very strong in general. Kind of depends on the context, but in general. If it's in the 0.8, we call that strong. If it's in the 0.7s, we call that, you know, moderately strong. Anything below 0.7 in general, we refer to as weak. Okay, so so there you go. Okay, but yeah, in order to judge, but so the R value does not tell us linearity. It tells us strength and direction, whether it's positive or negative and how strong it is. The residual plot, that is a nice, lovely residual plot. That residual plot would tell you that the linear model is a good model. We don't want any sort of noticeable curve. That would be a bad residual plot. Okay, there's a noticeable curve. We want the residual plot to be randomly scattered. So, so in regards to linear regression, be able to interpret a computer printout, also be able to interpret these values, A, B, S, R, and R squared. So you remember in the computer printout, let's say something like this, you've got to be able to interpret that. And so remember, this first number, that is A, and that is B. We'll never use these numbers here. All right, these numbers are important in linear regression inference, which we did in chapter 12, section 3. There's S, that is the average amount predictions will be off. There's R squared, the percent of the change in Y that can be explained by the change in X, and we'll never use that. You have to be able to interpret these values, which you can go back and look at one of our videos reviewing linear regression if you want to do that, or if you want, you can contact me and I'll do it again for you. So you please be able to interpret all of these values. All right, the residual of a point is how far above or below the line the point is from the least squared regression line. The residual is the actual Y value minus the predicted Y value. The predicted Y value is what you get when you plug the X value in to the least squared regression line. So if the regression data is linear, the residual plot will show randomly scattered points, like we talked about a second ago. Okay. Number 15, when evaluating how good a least squared regression line is, discuss the scatter plot, the R value, and the residual plot. So if you have the equation of a least squared regression line, all right, and you want to evaluate it, you'd look at the scatter plot. And if the scatter plot is nice and linear and strong, you would say, that's good. And if the R value, let's pretend the R value is really strong, so that's going to be an R value of like 0.95 or something, you would say, that's good. All right, but you have to have all three things: a nice randomly scattered residual plot. That's good. So in this case, if the residual plot is that, and then that's the scatter plot, and that's the R value, we feel great about using our line for a predictor. So, okay then. So let's see. So that's how you evaluate that. So now let's talk about data collection. A random sample is one in which each member of the population is equally likely to be chosen. Random sampling is likely to result in a representative sample, and random sampling ensures that there would not be bias in the selection process. That's important to know. Guess what? All of this stuff is important to know. Anyway, but that's important to know. All right, be able to explicitly state how to randomly select a sample from a population. In general, you must assign each member of the population a unique integer from 1 to big N. Big N is the population size, not the sample size. The sample size is little n. Then use a random number generator to create n unique integers from 1 to n. then state that the individuals with these integers are in the sample, okay? Number 18, stratified sampling is done by dividing the population into groups, strata, and selecting some members from each. This should be done if it is believed that the groups differ in regards to the relevant issue. If done properly, stratified sampling will result in less variability. So what's going to happen if you properly stratify is your estimate's going to be more precise. So, okay. So then number 19, all right, when explaining a confounded variable situation, make sure you clearly state how you think the levels of the variables are related. Make the connections between the explanatory variable, the response variable, and the other variables. Show how all of those three variables are related. Number 20, in an experiment. An experiment is a type of study where treatments are imposed on the units, okay? And establishing causation between two variables is generally done through a controlled experiment, controlled comparative experiment, where they've been randomly assigned into groups. So if it's an experiment where they've been randomly assigned into comparative groups, we can use the word cause. Otherwise, we just have correlation. All right, okay. When writing an experiment, make sure you discuss how the units are randomly assigned, what's happening in the treatment groups, and how the results are compared between the groups. You got to do all three of those things when you're asked to design an experiment. Number 23. Now let's talk about probability. If you're given the probability of event A and then also the probability of event B, all right, and then the probability of event A and B, it may be best to do a Venn diagram. Okay, frequently it's best to do a Venn diagram. If you're given the probability of one thing, probability of the other, and then the probability of both. That's a Venn diagram problem. So, and if you need to review any of the probability stuff, I made a probability video. You can go back and look at that, where I did a Venn diagram, and I certainly did a tree diagram as well. If you're given conditional probabilities, the probability of one thing given another, it may be best to create a tree diagram to answer the questions. And if neither one of those work, there's a good chance you're going to be using the formulas or the multiplication rule. All right, so the word or in probability means to add the probabilities. If it says the probability of this thing or that thing. Remember, whenever you add probabilities, you must subtract any overlap between the events. The generalized addition rule in your formula sheet is the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. All right, so that formula, once again, is on the front page of your formula sheet right there. So there's the generalized addition rule. So then we have number 26, the probability of event A given that B has occurred may be found by using the conditional probability on your formula, which is that. All right, and so conditional is the probability of A given B is the probability of A and B over the probability of B. So that is that. Okay. And then these two you have to memorize in 27. To show whether or not two events are independent, you could show either one of these things. Both of these things would be true. If they're independent, the probability of one thing times the probability of the other thing is equal to the probability of both A and B. Also, if they're independent, the probability of one thing given another is just the probability of the first thing. Okay, so either one of those will show independence, and you need to be able to use both of them. All right, number 28, when finding the probability of multiple events, you multiply. Okay, in order to multiply events, they must be independent, or you must take into account their conditional nature. All right, then we have binomial. Binomial problems occur when you are given a set probability success, P, a fixed number of trials N, and are asked the probability of a certain number of successes, S. So when they give you a probability of something occurring, and then they say, we do a certain number of trials, okay, and what's the probability of a certain number of successes in those trials, that is going to be a binomial situation. And binomial formulas are here. Here's the binomial formula. Of course, on our calculator, we have binomial CDF and binomial PDF. This is in essence the one for binomial PDF. There's the mean for a binomial situation, just N times P. And there's the standard deviation for a binomial situation. So we have that. All right. And so we have binomial. Okay. Then for a sampling distribution. All right. The standard deviation for a sampling distribution is for a mean, it's sigma over the square root of N. The standard deviation for a sampling distribution for a proportion is the square root of P times 1 minus P over N. So that's the next page in your formula sheet. So in regards to sampling distributions, okay, for a proportion, it's that. okay? And if we're using the estimate p hat for it, we call it a standard error, by the way, it's that. And then for a mean, it is that. For a sample mean, there, it's sigma over the square root of n. And if we're using S as an estimate for sigma, it's S over the square root of n, we call it the standard error. Number 31, anytime you create a confidence interval, make sure and state the type of inference, verify the assumptions, the conditions, do the mechanics, make the interval, and then state the ending, interpret the interval in context. So you have to do the acronym TAME whenever you do a confidence interval. When interpreting an interval, which is the last step there, you would say, I am whatever percent confident is in the problem, like 95%. Let's say it says 95%. I'm 95% confident that this interval captures the parameter P or mu, or the difference in the parameters if it's a two sample thing, and then state it in context. So that's interpreting the confidence interval. Now, interpreting the confidence level is a different thing. In other words, if they say, what do you mean by 95% confident? Or to interpret what it means by 95% confidence, you would say, if we were to do the same procedure many times and create many intervals, 95% or whatever the percent was given in the problem of the intervals would capture the parameter, and you would then define what the parameter is, whether it be P, mu, or the difference in the P's or mu's. Okay, so there we go. So that is that. Just a few more tips I have for you. Number 34, anytime you do a hypothesis test, make sure and do 5 things, 5, okay? State the type of inference, state your hypotheses, your null hypothesis, your alternative hypothesis, verify the assumptions, the conditions, which is basically SIN in most of them. In other words, is it a simple random sample or random? Do we have independence? Is our population big enough, in other words? And do we have normality? Okay. Of course, if it's chi-squared, it'd be your expected counts have to be at least 5. Do the mechanics, which means find the test statistic and the p-value and the degrees of freedom, if it's a t-test or a chi-squared test, and then state the ending, which is draw your conclusion with your p-value. All right. So when drawing a conclusion with a p-value, make sure you compare the p-value with the alpha that's given in the problem. If one's not given in the problem, use 0.05. If the p-value is less than alpha, we reject the null and say you have convincing evidence in the alternative, which you state in context. If the p-value is greater than the alpha value, you fail to reject the null hypothesis and you do not have convincing evidence for the alternative, which you state in context. Number 36, if you're asked to interpret a p-value, which is different than drawing a conclusion with p-value. Drawing a conclusion with p-value means compare it to alpha and reject or fail to reject the null. If you're asked to interpret a p-value, that means to discuss it as a conditional probability. Now, how do you do that? Well, a p-value is the probability of getting sample data as unusual as what we did, given that the null is true. So you would just, if you're asked to interpret the p-value, you would say, well, if the null is true, in whatever state, whatever it is in context, the probability of getting sample values is unusual as what we got, is whatever the p-value is. There you go. All right, and then lastly, be able to identify and use the formulas on your formula sheet, know which ones are important and which ones are not important. And this isn't really that much emphasized, but anyway, let me quickly go through. This is your formula sheet. This will be provided to you. As far as the which ones, it's unlikely. There's the formula for the standard deviation. They are on your formula sheet, but it's very unlikely that you would have to use the formula for standard deviation or the formula for R. That has never happened on the exam, and I really feel like it wouldn't. These formulas for linear regression, they're important for you to be able to use, and there's the very important formulas for probability, just basic probability and conditional probability there. And then for discrete random variable, these could come up. For binomial, these could come up. For geometric, these could come up. And then your every test statistic has this basic formula, statistic minus parameter over standard error. Every confidence interval has this basic formula, statistic plus or minus critical value times the standard error. There's our chi-squared statistic. That could certainly come up. Then our formulas here for our sampling distribution formulas for standard deviations there, those could come up. And for our standard error, whether it be used for an interval or for a test. All right, that's certainly free game, as are these things, the similar things for means. These things could certainly come up. And then at the bottom here, this is extremely unlikely. These have never come up on the AP Stats exam before. And so I would you know, I would not worry about these at all. But so those are the formulas that'll be useful for you. Okay, thanks for watching my video. If you have any questions, I know I went through the whole course pretty much, a little survey kind of through all the major topics in the course. So please send them to me, and hope you have a great day.